Hello, my name is Leandro Minko, and I'm going to present an investigation of cross-project learning in online just-in-time software defect prediction. Just-in-time software defect prediction, or JIT-SDP, consists in predicting whether software changes are defect-inducing or clean based on features describing such changes. Typically, what people do is to adopt machine learning algorithms to build JIT-SDP models based on previous within-project changes known to be defect-inducing or clean. The problem of doing that is that in the initial stage of software projects, we don't really have much within-project training data to use for creating these predictive models. So these predictive models may not really perform very well during the initial stage of software projects. To overcome this problem, people have investigated the use of cross-project data, and they found that models created only with cross-project data achieved similar predictive performance to models created only with within-project data. But the problem of existing work on cross-project data is that they assume that we never receive any new within-project or cross-project training example over time. And in reality, JIT-SDP is an online learning problem where additional within-project data is received over time and can be used to improve predictive models. So it is unknown whether and to what extent cross-project training data is helpful in realistic online learning scenarios. It could be that cross-project training data is only really helpful at the very early stage of a software project when there is very little within-project training data, or it could be that cross-project training data are useful for prolonged periods of time, especially considering that the JIT-SDP is a class imbalance learning problem that may suffer from concept drifts, which are variations in the defect generating process which can hinder predictive performance over time. So the aim of this study is to investigate if and to what extent cross-project training data are helpful in realistic online learning scenarios. We investigate online JIT-SDP approach that fully respect chronology of the data, including the commit time and the labeling time of the training examples. We investigate a within-project approach where within-project training data arise over time and can be used to update our predictive models. And we investigate cross-project approach where both cross-project and within-project training data arrive over time and can be used to update our predictive models. Our all-in-one approach uses both cross-project and within-project data together to train a single predictive model. Our filtering approach will filter out some of the cross-project data that are too dissimilar from the most recent within-project chains. And our ensemble approach uses different predictive models trained on data from different projects and then combine them into an ensemble to provide predictions. Our first research question is, can cross-project data help to improve predictive performance in the initial phase of a project when there is little within-project data available? For how long and to what extent? We performed experiments with 10 open source projects using both OOB and ORB as base models for our approach, and we report here the G-means, which are the geometric means between the recall on the clean and on the defect-inducing class. We found that the filtering and the all-in-one approach were better ranked than the other approach, and in particular, the within-project approach obtained the worst rank. These ranks were produced based on Scott knot. The effect size were typically large, and the G-means were up to 53.9% higher when using the cross-project approach. This initial period where there is little within-project training data to lead to well-performing within-project models lasted between 461 and more than 6,000 commits, so it's a significant period of time. We also collected 3 proprietary projects for this study, and we found somewhat similar results in the sense that filtering and all-in-one approach were useful for improving predictive performance. Our second research question is, can cross-project data help to prevent sudden drops in predictive performance which may be caused by concept drift, and to what extent? And I show you here some sample results. For instance, you can see that during this period of time and this period of time here, the within project approach, which is showing back, has severe drops in predictive performance, whereas the cross-project approach, which are shown here and here, have much smaller drops. Our third research question is, what is the overall effect of using cross-project and within-project data together on the predictive performance throughout the development of software projects? And we found, based on our open source data, that the filtering and the all-in-one approach were better ranked than the other approach, both in terms of G-mean, recall on the defect-inducing class, and recall on the clean class. The improvements in G-mean were up to 16.88%, and the effect size were typically large. Now, this is an interesting result because in the offline learning literature, which ignores concept drift and the initial period, cross-project data led to similar rather than better results than within project models. And here we found that combining within project with cross-project data and using them to train predictive models can actually lead to better results than within project models. Our results with the proprietary data were again similar in the sense that the all-in-one and the filtering approach were the best ranked. And in particular, I would like to mention here that the open source data used as cross-project data was helpful for improving predictions on the proprietary data. This suggests that the amount and variety of data is important when creating JIT-SDP models. Still, we found that having a good number of within-project training examples was still important, both for the open source and for the proprietary predictions. So in conclusion, we performed the first study of cross-project learning for JIT-SDP in a realistic online learning scenario using both open source and proprietary data. We found that the all-in-one and filtering approach can prevent very low predictive performance at the initial phase of the project. We found that the cross-project data can help to reduce or eliminate drops in predictive performance that may be caused by concept drift. And we found that the all-in-one and filtering approach can improve overall predictive performance compared to within-project learning. The amount of both within-project and cross-project training data was found to be important. Thank you, and I'm happy to take any questions.